We're dealing with a clustering problem using Scikit-Learn's BisectingKMeans. I've run the algorithm, and one cluster is way bigger than the rest. This makes me wonder why and what I should do next. Is this a failed clustering, or could there be a different explanation? I think this statement is too strong. Just because one cluster is large doesn't automatically mean the clustering failed. The data might genuinely have one huge group and some smaller ones. I'm going to look into the other possible reasons first. Let's consider increasing the number of clusters. BisectingKMeans works by repeatedly splitting clusters. Increasing the n_clusters parameter might help split that large cluster into smaller, more similar groups. This seems like a good thing to try. Here's another thing to think about. The starting point of the algorithm, centroids. Just like starting a race at a different point, changing the starting position of the clustering algorithm, using a different random seed with the _random_state parameter, might give me a different final arrangement of points into clusters. I'll investigate this too. This is an important point. Maybe the data itself just has this structure. It's possible that one large group and several small ones is truly how the data is organized, and no matter what clustering algorithm I use, I'll still get that same result. I need to consider that. This whole analysis is about understanding the results I got from a BisectingKMeans clustering algorithm and what that means. I'm trying to diagnose a situation where one of my clusters is way larger than the others. What went wrong, or is everything all right? This is just the instruction to pick all the answers that are true from the statements provided. It's not an actual step in solving the problem. This section title tells us that we'll be focusing on how to interpret the results we get from using the BisectingKmeans algorithm in machine learning. The BisectingKmeans algorithm is a type of clustering technique that aims to group similar data points together. We're presented with a situation where a clustering algorithm has run, and one cluster is much bigger than the rest. I'll be guiding you to figure out why this might be happening, and what we can do about it. This statement suggests that a large cluster automatically means the algorithm failed. I disagree. Just because one cluster is big doesn't mean the clustering is bad. It could just reflect how the data is naturally grouped. Here, we're talking about adjusting the algorithm. N_clusters is the number of clusters you want the algorithm to find. If I increase this number, it's like I'm giving the algorithm more chances to find smaller, tighter groups within the data. That could make the big cluster more manageable. This is a crucial point. It's possible that the data itself naturally falls into this pattern: a big main group and some smaller, distinct groups. The algorithm isn't necessarily to blame, it's just reflecting what's already there in the data. The BisectingKmeans algorithm starts by picking random points as centroids, the centers of the clusters. Where these starting centroids are placed can greatly affect the final result. Think of it like trying to sort marbles based on color, but you start sorting in a random spot. Changing the starting points, by using a different random_state, may help get a better clustering. I'm analyzing the results of a BisectingKmeans clustering algorithm. This algorithm is a type of K-means clustering, which groups data points into clusters based on their similarity. Bisecting refers to how the algorithm works. It repeatedly splits clusters in two. I disagree. Just because one cluster is large doesn't automatically mean the algorithm failed. The data itself might simply have one dominant group and several smaller ones. I think this is a good idea. Increasing the number of clusters, n_clusters, might help. The algorithm works by splitting clusters. More clusters give a finer-grained view, and might break up a large, potentially heterogeneous cluster into smaller, more similar ones. That's a key point about K-means algorithms. The starting positions of the centroids, cluster centers, are important. Since the algorithm is iterative, a different random start could lead to different cluster assignments. Here's the situation. I've used the BisectingKmeans algorithm with 5 clusters. I noticed that one cluster, cluster 3, is much larger than the rest. I've got some possible reasons and solutions to explore, which are given as multiple choice questions. This is absolutely true. Sometimes, the data just naturally groups this way. The algorithm isn't flawed if the underlying data shows a dominant cluster. I'm analyzing the results of a bisecting k-means clustering algorithm. This algorithm is used to group similar data points together. I'm focusing on how to interpret the results when one cluster is much larger than the others. The key is to understand if a large cluster indicates a problem with the algorithm or if it reflects the actual data structure. I've run a clustering algorithm and found that one of my 5 clusters, cluster 3, has many more data points than the others. This is unusual, and I need to figure out why this happened and what I should do next. I'm evaluating whether the large size of cluster 3 automatically means the algorithm failed. I'm saying, no way. A large cluster doesn't always mean the algorithm is wrong. The data might just naturally have one large group. I'm considering whether increasing the number of clusters would help. Bisecting k-means works by repeatedly splitting clusters, so increasing the number of clusters might break down the large cluster into smaller, more similar groups. It's worth a shot. I'm thinking about the possibility that the data itself might have one big group and several smaller ones. It's not necessarily a problem with the algorithm. Maybe that's just how the data is structured. This instruction tells me that multiple options might correctly explain the situation. I need to carefully consider each statement. I'm analyzing the results of a bisecting k-means clustering algorithm, specifically focusing on how to interpret situations where one cluster is much larger than others. In my clustering, I found that one group, cluster 3, has way more data points than the rest. This is my starting point for understanding why this might be happening. It's possible that my data inherently groups this way. The data itself might just have one big cluster and several smaller ones naturally. This is completely independent of the clustering algorithm itself. I need to consider this possibility. Maybe I should increase the number of clusters, the n_clusters parameter, in my algorithm. This could split up the large cluster into smaller groups. I could create a more refined clustering in this way. The starting points, centroids, for the algorithm really matter. Bisecting k-means is sensitive to the initial positions of these centroids. If I try it again with a different random starting point, using a random_state, I might get much better results. Just because cluster 3 is big doesn't mean the whole clustering failed. It's not automatically a sign of failure. I need to look beyond just the size of one cluster. I'm analyzing the results of a clustering algorithm called bisecting k-means. It's used to group similar data points together. We ran bisecting k-means, aiming for 5 clusters. Unexpectedly, one cluster ended up much larger than the others. This is the situation I need to understand. I'm trying to figure out what this result means and what I can do about it. Several explanations are possible. I think that increasing the number of clusters we're aiming for might help. It might split up that large cluster into smaller, more similar groups, which would make the results more meaningful. This is because bisecting k-means works by repeatedly splitting clusters. The starting points for the algorithm, centroids, affect the final results. Using a different random seed, a parameter you can control, could change those starting points, potentially producing better clusters. It's also possible that the data itself just has one large group and several small ones. Maybe the algorithm is working correctly, it's just reflecting the actual data structure. It's tempting to think that a giant cluster means the algorithm failed, but that's not necessarily true. The data might actually have this structure. So, I'd reject this explanation. I'm analyzing the results of a bisecting k-means clustering algorithm. It's a technique used to group similar data points, like customers with similar spending habits. I'm focusing on how to interpret the results, especially when one cluster is much larger than the others. Let's say I'm working with customer data and I've used bisecting k-means with 5 clusters. I notice that one cluster, cluster 3, has way more customers than the others. This observation triggers a deeper investigation into the quality and meaningfulness of my clustering results. Given that observation about cluster 3, I need to determine which statements correctly describe the situation and appropriate next steps. I must carefully evaluate each statement's accuracy in light of the clustering algorithm's characteristics and potential data limitations. I'm considering this statement. The large size of cluster 3 definitively means the bisecting k-means algorithm failed. I find this to be incorrect. A single large cluster does not automatically mean the algorithm failed. It might just reflect the data's natural structure. Here, we're considering increasing the number of clusters, n_clusters. I see that increasing the number of clusters might help. It could split cluster 3 into smaller, more manageable groups, leading to a more refined clustering. This statement focuses on how the initial positions of the cluster centers, centroids, influence the outcome. I agree, BisectingKMeans is sensitive to this, so using a different random starting point might give better results. This statement suggests the possibility that the data itself is structured with one large group and several small ones. I think it's true, the clustering algorithm isn't necessarily wrong. The data might naturally exhibit this structure.